Okay, let's start simple. Imagine you're at an arcade shooting marbles at a board with two tiny gates. If you aim carefully, each marble goes through either the left gate or the right gate, right? You'd expect two neat piles of marbles behind the gates. But what if I told you that marbles, or anything tiny like light or electrons, don't play by those rules? Buckle up, folks. This is the double slit experiment, and it's about to break your brain. Let's talk about waves. Drop a pebble in water and ripples spread out. If those ripples hit a barrier with two gaps, something cool happens. The waves go through both gaps, spread out, and crash into each other. Where peaks meet, you get bigger waves. Where a peak meets a valley, canceled. This creates a striped pattern, bright and dark bands. Scientists call this interference. Pretty, right? But waves are messy. They don't pick a lane. Now, particles like marbles, they're polite. They go through one slit or the other. No drama, no interference. Two neat piles. For centuries, scientists thought everything was either a wave or a particle. Then along came light. Enter Thomas Young, a 19th century genius with a flair for drama. He shined light through two slits and saw interference stripes. Aha, he cried. Light is a wave. Newton's particle theory? Oof, but wait, it gets weirder. Fast forward to the 1900s. Scientists got fancy and shot light one photon at a time. If photons are particles, they should stack up in two piles, but nope. Over time, an interference pattern emerged. Each photon acted like it went through both slits and interfered with itself. Let that sink in. A single particle becomes a wave, splits into two, interferes, and then poof. Becomes a particle again when it hits the screen. Schrödinger's cat isn't the only thing confused here. Even Einstein called this spooky. Here's where it gets really weird. Scientists thought, let's watch which slit the photon uses. They added detectors, but the moment they looked, the interference pattern vanished. The photons suddenly acted like good particles, making two boring piles. In the delayed choice experiment, physicists pulled a sneaky trick. They waited until after the photon passed the slits to decide whether to measure its path. Guess what? The photon's past behavior changed based on the future measurement. It's like choosing your breakfast after you've already eaten it. Next up, the quantum eraser. Scientists first measured which slit the photon used, killing the interference. But then they erased that info, and the stripes came back. It's like your mom finding your browser history, then you hitting delete and pretending it never happened. The universe is forgiving. Just when you thought it couldn't get weirder, in 2023, scientists made slits. In time. Instead of two gaps in space, they created two ultra-short moments when light could reflect off a material. The result? Time itself interfered. All this weirdness isn't just philosophy. Quantum computing, ultra-secure encryption, and even better phone screens rely on these principles. That time slit experiment? It might help build 6G networks. Take that, Newton. So what's the takeaway? Reality isn't what we thought. Particles exist in multiple states until observed. The past isn't fixed. And the universe? It's less like a clockwork machine and more like a choose-your-own-adventure book written by a caffeinated raccoon.